Okay, we're going to look at some properties of the definite integral. The first is basically the integral from a point A to a point B on a curve. And if you notice, the area is 5.33 when I'm going from 1 to 3 underneath this curve. If I move A in front of B and B back to 1, what happens is now I'm integrating from 3 to 1, all right, and notice how that is the negative of the area underneath the curve, between the curve and the x-axis. If I go back to A to the left of B, but I'm completely underneath the x-axis, the area between the curve and the x-axis when it's below the x-axis is also the negative of the area. Alright, so we can get negative areas by integrating from right to left, and also when the curve is underneath the x-axis. If A and B are the same value, the area underneath the curve from A to A, or when A and B are the same, is of course 0 because there is no area. If I want to look at the combination of area, I'm going to put my A back to 1, my B back to 3, and suppose I want to split that and move a C somewhere around 2. Notice that from A to C is 1.79, from C to B is 3.54, and those add up to the total of 5.33. Now, what's interesting is if I move C beyond, way out to 4, well, let's make it about 3.5. Alright, now the integral from A to C is greater than the original area, 6.78, but from C to B now I'm integrating from right to left. That becomes negative, and 6.78 minus 1.45 takes me back to that 5.33. Alright, now the real advantage of going from A to C plus C to B instead of A to B is if you have the situation similar to what we have here. Suppose we want, and I'm just going to get these points approximately at certain spots. Suppose we want the area from the point A to the point B. Alright, now what's actually happening here is the area to the right of the intercept is a positive value, and the area from the A to the x-intercept a little bit less than 1, that's a negative. So those two values are being subtracted, one from the other. Just to double check, that's a negative, and this would be positive, and the total is the one area minus the other area. So if we wanted to split those and put our C value right there, we would now have the option of taking the absolute value of that green result and coming up with a full tally of the orange plus the absolute value of the green. And there are some situations where we want that absolute value of the areas or the integrals. All right.